In Episode 7, Docker Compose let you run a whole multi-container application with one file and one command. This episode, we start Kubernetes, and for one episode, we're going to slow down and build the mental model before we type a single command. Here's the honest limitation of everything so far. Compose runs beautifully on one machine. If that machine dies, everything on it dies with it. If traffic triples overnight, there's no built-in way to spread load across more machines. If you want to update your app without a gap in availability, you're on your own. Production workloads need more than one machine can promise. Kubernetes exists to solve exactly that, running containers reliably across a whole cluster of machines instead of just one. A Kubernetes cluster has two kinds of members. The control plane is the brain. It makes every decision about what should be running and where, but it doesn't run your application itself. Worker nodes are the muscle, ordinary machines that actually run your containers, taking instructions from the control plane. Inside the control plane, for pieces do the real work. The API server is the front door. Every command, every tool, every other control plane component talks to Kubernetes exclusively through it. ECT is the cluster's memory, a database storing the current and desired state of absolutely everything. The scheduler decides which worker node a new workload should land on, based on available resources. And the controller manager is the part that never stops watching, continuously comparing what's actually running against what you said you wanted and correcting the difference. That last point is worth sitting with, because it's the single biggest shift from everything in episodes 1 through 7. With Docker, you ran commands and things happened. With Kubernetes, you declare a desired state. I want 3 copies of this running, always. And the controller manager enforces that state forever, without you doing anything else. A worker node crashes at 3 in the morning, and Kubernetes replaces what was lost automatically, because the desired state still says 3. On the worker node side, 3 components carry out the control plane's instructions. The kubelet is the node's local agent, taking orders from the API server and making sure the right containers are actually running. The container runtime is what actually starts and stops containers. Conceptually, the same job Docker's engine has been doing this entire series. And Kubeproxy handles the networking rules that let traffic find the right container on the right node. One more piece of vocabulary before we close. In Kubernetes, you don't run a container directly. You run a pod. A pod is a thin wrapper around one or more containers that share a network namespace and storage, and it's the smallest unit Kubernetes schedules and manages. Most of the time, a pod holds exactly one container, but the wrapper is what gives Kubernetes a consistent unit to work with regardless of what's inside. Let's recap. A cluster is a control plane plus worker nodes. The control plane, API server, ECT, scheduler, controller manager, decides what should exist. Worker nodes, kubelet, container runtime, Kubeproxy, make it real. And a pod, not a bare container, is the unit Kubernetes actually schedules. That's the whole mental model. In Episode 9, we install a local cluster, meet kubectl, and deploy your first real pod. Subscribe so you don't miss it. See you then.